Well, welcome everyone to a stage of the TKG Art. My name is Robert. I'm a consultant with ITQ. And today we are going to cover the three different versions of Tanzu Kubernetes Grid. You heard that right, there are three different versions in case you didn't know. So the usual disclaimer. So this is a slide I was trying to include in my decks. It's basically the way I see the Tanzu portfolio as it is today. I've had to edit it today. I've added a few things, mainly Tanzu Community Edition, which I'll talk about a little bit later. Today we're going to concentrate on basically the bottom part of this slide. We're going to concentrate on the runtime part of the Tanzu portfolio, which is vSphere and Tanzu Kubernetes Grid. Now, when we talk about Tanzu Kubernetes Grid, what we're talking about actually is VMware's version of a managed Kubernetes, or sometimes known as a Kubernetes distribution. So what's a managed Kubernetes, or what's a Kubernetes distribution? Well, Kubernetes, for the longest time, it used to be quite hard to install. A lot of moving parts, a lot of layers to it. Wasn't that easy. And then various tools came along, open source tools, to make Kubernetes itself easier to install. But to make Kubernetes actually work in production, you need more than just Kubernetes. You need things like an external load balancer. You need a way to manage the life cycle of the VMs that the Kubernetes installation is living inside of. You might want an authentication mechanism or something to make sure that you're not just logging in with the default admin token. And a little bit newer, this one, you might want a way of very easily installing or spawning more Kubernetes clusters. There are various ways of doing that, older ways and newer ways. And that's one of the key differences in how these TKG versions differ from each other. So today we have basically three different versions, three different versions of Tanzu Kubernetes Grid. I'll start with the one on the far right, actually. Maybe I should have swapped them around in this slide. The oldest version, Tanzu Kubernetes Grid Integrated Edition. The name can be a bit confusing because it says integrated. Well, integrated in what? It's not integrated in anything, really. It is a rebranding of what used to be called Pivotal Container Services. Pivotal was originally spawned out as a company from VMware about 10 years ago. And about 2 years ago was reacquired by VMware. And they're actually the first part of VMware that built a managed Kubernetes offering called Pivotal Container Services. It's been rebranded Tanzu Kubernetes Grid Integrated Edition, or TKGi for short. And it actually, the mechanism that it works on kind of predates Kubernetes a little bit, which is interesting. But we'll get into a bit more detail in a second. Then we have the two new guys on the block. Tanzu Kubernetes Grid, it's just called that, TKG, Tanzu Kubernetes Grid, and then something called vSphere with Tanzu. Now, in the kind of inside VMware or in various places within the community, you might see these versions referred to as TKGm and TKGs. And the reason is they're both kind of TKG. They both contain the same core Tanzu Kubernetes Grid managed Kubernetes runtime. The only difference is that in vSphere with Tanzu, they've taken TKG and they've made it a part of vSphere. They've actually embedded it into vSphere and into ESX. And in that context, it's sometimes called the TKG service, hence TKGs. TKG, or Tanzu Kubernetes Grid, full stop, on the other hand, is a standalone version of TKG. It's the first version that really kind of existed because it's the core technology that TKG consists of. And it's loosely coupled. It's not integrated with vSphere, which means you can install it on many clouds. So that's where the M comes from, M for multi-cloud. And I'll be referring to these different versions by these shorthand abbreviations. But at the top of this slide, you see their official marketing names. Now, I'm not going to go into detail here with everything you see in this particular slide. This slide's here for review because you're going to get the slides afterwards anyway. The point of this slide is to show you that there are some significant differences between these versions. And to give you an idea of where these major differences are, for one, they manage the VMs in different ways. The oldest version of TKG, TKGi, uses a technology called BOSH to lifecycle and manage the VMs and the Kubernetes installation that lives on those VMs. The two newer versions of TKG, TKGm and TKGs, they use something called Cluster API, which I'll talk about a bit more in a second. There are also differences in the kind of networking options you get around these different versions of TKG and different ways to manage them, different UI, different CLI tools. And the options for which version of Kubernetes you can use and which base OS image you can use also differ. And they differ in how those images are delivered between these versions. Now, in the two newest versions of TKG, it's very easy to have those products create or spawn additional Kubernetes clusters for you. They're using a technology called Cluster API. Cluster API is part of the Kubernetes project. And it's kind of it's one could say that TKG is a VMware productized version of basically Cluster API. Cluster API means you create a Kubernetes cluster, which you call the management cluster. And then from that management cluster, you can then spawn additional Kubernetes clusters. And those Kubernetes clusters, they are managed in Kubernetes. It's kind of Kuberneteception, as if they were just native Kubernetes objects, like a pod or like a load balancer. So you're using Kubernetes to make more Kubernetes, if you can still wrap your head around that. So if we put these three versions side by side, you get a few different options. Like I said, the two new versions of TKG are kind of the same technology in the core of them. They're both TKG. But then you have this version that's integrated in vSphere, and you have a version that is not integrated in vSphere. And then you have the older version, which uses a completely different way of creating the Kubernetes VMs. So when you run or when you install these TKG versions, what you want to end up with is Kubernetes clusters that you can run workloads in. Now, every single one of these versions just does that. That's kind of the basic point of it, right? But with vSphere, with Tanzu, vSphere with Tanzu, so TKGs, you have an additional option. They did something interesting there. They made it so that you can actually run pods natively inside ESX. So some of you might remember this being referred to as Project Pacific, which was announced several years ago now. So you can spawn complete Kubernetes workload clusters to run your workloads in there, or you can run the pods natively inside ESX. The standalone version, TKGm, doesn't do that. It only can spawn complete workload clusters, and that's where you run your workload containers in. Now, it should be noted that this option to run these pods inside ESX natively requires NSXT today. And the oldest version, TKGi, is completely dependent on NSXT, or by default at least. There are options to use Antria in the latest versions of TKGi now, but it's kind of made to be used with NSXT. TKGm, on the other hand, has no NSXT integration at all. You could integrate it with NSXT using what's called the NCP plugin, but it's probably not gonna work great. So let's look at the oldest version first. I'm just going to very briefly cover this because it's not that interesting anymore, because it's not really being sold anymore. A lot of people are still running it though. So you still run into TKGi all over the place, especially former Pivotal customers. Because VMware has obviously inherited this product from those Pivotal customers. I would say this is the most mature version. It's also today still almost the most fully featured version. For example, it's the only version of TKG that supports Windows containers. The other two versions don't yet. They probably will soon, but they don't today. This is a screenshot of how you use TKGi. You use a command line tool to manage it, and it's interesting when you actually kind of list all the things the command line tool for TKGi can do. It gives you kind of that nice little summary of my previous slide. What do you want from a managed Kubernetes solution? Well, you want to be able to create clusters. You want to be able to customize the clusters. You might want to do some customization around the networking. Literally, the kind of commands you see in this slide represent the kind of stuff that you would expect to be able to do with a managed Kubernetes solution. So I thought that was maybe worth showing. Like I said, TKGi relies on an older technology to manage the VMs, BOSH. It's now, while this product is older and it's not really being sold anymore, it is still supported by VMware. It's still being actively developed a little bit. I don't expect it to last very much longer. I expect that once the newer versions of TKG reach feature parity with TKGi, then TKGi will start to slowly fade out. TKGi relies on what's called the Pivotal system, or it's a framework that Pivotal created all of their products in. The other kind of the big famous suite that Pivotal is known for is Pivotal Cloud Foundry, their commercialized version of the Cloud Foundry open source software. All that software is always delivered in this form. You install an appliance called the Ops Manager. You install these products, like in this case TKGi, as a product or a tile inside this appliance, and you can manage it quite visually from here. It's quite easy to use, very intuitive. And when you create Kubernetes clusters using TKGi, this is what it ends up looking like in vSphere. All these VMs, they're all given random names. It's not very human readable, but it's not supposed to be, because you manage the whole thing using the TKGi tooling. You don't manage this stuff directly in vSphere anymore. And that's true for all these TKG versions. You do the management somewhere else. And the VMs are created for you. You don't need to worry about them anymore. Tanzu Kubernetes Grid multi-cloud. This is basically the core Tanzu Kubernetes Grid. Whenever VMware refers to Tanzu Kubernetes Grid, full stop, this is the version they're talking about. This, like I said, it's a standalone product, so it'll run in any cloud. It runs in vSphere 7, but it also runs in vSphere 6.7. It'll run in Azure, it'll run in Amazon natively on EC2 instances. So it's quite flexible. It doesn't require a lot of networking preparation either. All you need is a bunch of port groups or VLANs, and you can get started with this. You control it through something called the Tanzu CLI, which is it's just Tanzu on the command line. It is very much open source based, meaning it's very much a kind of almost a raw translation of Kubernetes and the Cluster API project and some other stuff you need to make Kubernetes work, like a built-in load balancer for the Kubernetes API, which in this case is kubevib. So it's based mostly around open source software. It's extendable with something called packages, which add, kind of easily add some features to Kubernetes, like Prometheus and Grafana, Contour if you need an Ingress controller, and it and like I said, it doesn't come with NSXT integration, but it does integrate with another NSXT product called the NSX Advanced Load Balancer, which is actually the Avi load balancer product, which was acquired again, I think 2 years ago now. So it integrates and pairs really nicely with that. So and that's a very professional and very scalable and high performance load balancing solution. So in most cases where you'll do TKGm in vSphere, you'll probably be pairing it with NS6 Advanced Load Balancer or AVI. In public cloud, you'll probably be hooking into the public cloud's own load balancer. So in the case of Amazon, it would be Amazon's own kind of load balancer built into the VPC. When you install TKGm, it's kind of interesting process. You have to first create a bootstrap machine. Could be your laptop, could be a separate workstation. It has to be able to run Docker. And when you run the installer, it first spawns a little Kubernetes cluster using Docker. So it's basically Kubernetes in Docker. It's the kind project. Within that, they import everything they need to build your management cluster, the cluster that you're going to do all your main management from, that's going to spawn your additional workload clusters. The thing on the right is the configuration for a typical TKG cluster. It's basically a flat YAML file, just keys and values. So it's actually very simple and very human readable to understand what's going on. So what the installation process looks like. There is a UI option, but it's optional. It brings you through all the steps, and it can do some pretty good logging of the installation as well. So if something goes wrong, it's quite easy to troubleshoot. And when you've installed your management cluster and then you use exactly the same type of config file, in fact, you can even copy paste your management config file to make your first workload cluster. This is what it looks like. In this case, I've got two. I've got just a very small clusters as a demonstration. This is what it looks like in vSphere. And like I said, these clusters are native Kubernetes objects. You manage them in Kubernetes using a combination of the Tanzu command line tool and the kubectl Kubernetes tool, because they're Kubernetes objects, so you can manage them like Kubernetes objects. Now, just announced yesterday is Tanzu Community Edition. Tanzu Community Edition is a free and open source and community supported version of a subset of the Tanzu portfolio. We're starting with basically the free version of TKGm. In fact, it's just a copy paste of TKGm. Actually, it's even better because it's including a bunch of stuff that TKGm doesn't have. For example, Docker runtime support. You can install the management cluster and the workload clusters, and you have them run on Docker on your laptop. That's what the normal TKGm version. It only uses Docker to spin up the bootstrap cluster, but then you have to target it somewhere, either vSphere or Amazon. But the TCE version, you can actually run it in Docker, which is kind of cool. So the TCE version, even though it's free, is in some ways more capable right now than TKGm. And finally, TKGs, vSphere with Tanzu. This is the version of TKG that's embedded inside vSphere. Now, like I said earlier, there are two different ways you can use this. You can either run pods natively inside ESX, or you can do what you can do with TKGm as well. You can simply spawn a workload cluster, which is a standalone cluster, it's just VMs, and then you run your workloads in that. So you have an option, but the options require some careful thinking. TKGm and TKGs, they have, they don't quite ever have parity with features. Sometimes they add something first to TKGs, or sometimes they add something first to TKGm. They have different capabilities. One of the interesting things introduced in TKGs is the ability to spawn not just Kubernetes clusters, but actually have Kubernetes spawn VMs that you can provide with your own config using cloud in it, which is kind of cool. So if you don't already have a product like vRealize automation, this would be a really cool way to create standardized VMs and using Kubernetes to control them. So the way this works is you take an ESX cluster and you enable it in something called workload management. You enable it for workload management. What that means is you're enabling it to run vSphere with Tanzu. You're enabling the Kubernetes functionality inside that ESX host cluster. And when you do that, this is kind of what it looks like. You can create namespaces in vSphere that also turn up as namespaces inside the TKGs management cluster, which in TKGs is not called the management cluster, it's called the supervisor cluster, to keep things simple. But the point with TKGs is that all of the stuff you can do inside the management cluster shows up in the vSphere UI as well. And TKGm doesn't do that at all. Remember, TKGm is standalone. It's not integrated with vSphere, but this is. And it enables a bunch of other stuff as well. These namespaces, they're basically resource pools, but with a bunch of other stuff tagged onto it. For example, RBAC, vSphere SSO. You can control who has access to these namespaces using the UI, using vSphere SSO, which you're probably already familiar with. You can do other things with the namespace as well. You can limit them because they're basically resource pools, right? So you can limit how much RAM, how much CPU, the clusters you build inside these namespaces are able to consume from your ESX cluster. So like I said, there's an RBAC model built into these namespaces, which means you might have to think a little bit about, well, who gets to manage the namespace? Do I give a developer group like a whole namespace, and can they then make their own Kubernetes clusters inside that? If I want to host Harbor, am I going to do that in a namespace that I control as an IT department? Or so you're kind of forced to think about who does what when it comes to Kubernetes, which is not unique to TKGs, by the way. I mean, you have to kind of think about these things in all versions of Kubernetes. But it kind of forces you down the path because it explicitly confronts you with those kind of questions. A note on these embedded workloads, very powerful, very cool, but there are some gotchas to watch out for. Running pods inside ESX means that the ESX hosts themselves are kind of your Kubernetes worker nodes. And the supervisor cluster is the control plane. It's that's where the K8s master nodes are. So your whole ESX cluster becomes a Kubernetes cluster. That also means that you only have as many Kubernetes worker nodes as you have ESX hosts. So you are a little bit more constrained in how you scale. Also, and this is very important, the version of Kubernetes running inside ESX is not an upstream conformant version of K8s, meaning there are some slight implementation differences between the way vSphere has done it inside ESX versus a normal Kubernetes cluster. That's usually no problem, but it can be a problem. So you have to watch out. If you want to use this, test your workloads very carefully. Just again, a reminder, I already mentioned it, that embedded mode requires NSXT today. If you don't have NSXT, you can't even use that. And then the only thing you can do is create, just like with TKGm, you spawn workload clusters and run your workloads or your customer workloads in there. When you install this, when you take one of these ESX clusters and you enable this for workload management, you go through a wizard. It's quite different than the TKGm wizard. It's also slightly less sexy looking, I have to say. And it's slightly harder to troubleshoot. It doesn't give you a running log like TKGm does. There is a log, but you have to find it inside the vSphere server appliance and tail it there to follow it to see if your workload enablement succeeded correctly. And when you install it, when you run it, when you build some workload clusters, this is what it looks like. So like I said, in the case of TKGs, when you do the embedded mode, your ESX hosts are your worker nodes, and you have 3 supervisor control plane VMs, that's your master nodes. And then if you want to spawn an additional separate standalone Tanzu Kubernetes guest cluster, then that's what it looks like in the middle there. It just creates a bunch of VMs, puts Kubernetes on them, and it's a standalone Kubernetes cluster. How you set these up is very different than in TKGm. Remember, TKGm was a flat file, just keys and values. In TKGs in vSphere with Tanzu, it's actually a YAML file, as I show at the top right here. So it's, but it's actually shorter. There are TKGs, because it's more opinionated, it's more tightly integrated in vSphere. It has more defaults. So you actually require less code to tell it to spawn an additional cluster. You need less information because it already knows a lot of stuff. This is what it looks like when you run those pods in embedded mode. The pods show up as if they were VMs. So that means you can kind of manage them like VMs, or tools that like managing VMs, like VROps, will treat these as VMs, but they're actually just pods. So that's the advantage of running embedded mode. But remember, you need NSXT to do this. Also, the advantage of running embedded mode is you get to see more stuff, because it's running the pods in ESX. So all of the statistics and all the information around those pods is directly exposed to ESX, which means you can view it in the vSphere UI. Finally, we're almost done. Some networking considerations. Again, I'm not going to go into detail on this slide. There's more for your review later. To remember, you need load balancing around Kubernetes, and you might also need layer 7 ingress. The different versions of TKG come with different options. The short of it is the TKGs and TKGm, they'll either work with NSXT or they won't. And almost all versions will use the NS6ALB or the AVI controller in some way or another. But this is moving, this is shifting, and this is kind of changing all the time. In the last version of TKGm, they introduced layer 7 ingress using the AVI controller, where first you would have to bring your own, like a contour or something. So this is still very much in motion. When you do use the NSXT integration, this is kind of what it looks like. All of the networking information that is happening around those pods is exposed directly in NSXT, which means you can firewall around it, you can manage it, you can see it, single pane of glass. Very cool. But remember, again, in TKGs, this only works if you use the embedded pods. And remember, those embedded pods have some disadvantage, so you have to keep that in mind. And if you use the N6 Advanced Load Balancer, this works very differently than NSXT. It's very much standalone, scales very differently. Great match for TKGm. And they just introduced full layer 7 ingress support for this as well. So it not only does layer 4 load balancing for your Kubernetes API, but it can also do layer 7 ingress for any application you deploy in Kubernetes. So to round up, takeaways. TKGm and TKGs are still quite new. What was happening up till now was that TKGm was kind of being used as the version where they would introduce changes first, and then that would trickle down to TKGs. But updates to TKGs often require changes to vSphere itself. So the big changes would come in a vSphere point release, like U2, U2C, U3 now. But now Tanzu Community Edition has come out. I expect now that the first changes will probably take place in Tanzu Community Edition first, and then trickle down to TKGm and TKGs later. But we'll have to see. Like I said, there's no feature parity between any of the 3 versions right now. I still consider TKGi to be the more mature one. It's still the only one that can do Windows containers, but that won't last long. The main integration options for networking are NSXT or the NS6 Advanced Load Balancer. Around TKGm, there are some options to bring your own, because in the end, it's just Kubernetes. So there's quite a lot of, a lot of options to swap bits and pieces, but not everything's supported, of course. In TCE Community Edition, there might be a bit more freedom around that. But the most important takeaway is, especially with TKGs, with vSphere with Tanzu, is to use these products effectively, you really kind of need to know Kubernetes, and not just how to install it, but you need to understand how to troubleshoot it. So you need to understand a bit about how you deploy applications on Kubernetes, how the load balancing works, how ingress works, how network policy works. So that means that if you're a vSphere admin today and you're asked to implement TKGs, because it's something you just turn on, you'll need to actually know a bit about Kubernetes in order to make good use of that and to understand how you use things like namespace and things like that. So that's it. I'd like to thank you for your time. Feel free to reach out to me. I'm in the VMworld Slack. I'm in the Modern Apps channel. I'm going to be there all week, so feel free to reach out to me there, and I'll answer any questions you have one-on-one if you want. Thank you very much. So I've got a question from in the chat from Christian. Customer having NSXT and planning to deploy TKGm. Would you recommend deploy it with NSXT integration or without? Well, there is no native integration with TKGm and NSXT. There is a technical way to do it using the same plugin that's used in TKGi called the NCP, but I'm not sure it's supported. So I don't think you have many options with if you want to utilize NSXT in combination with TKGm. If you really want to use NSXT, I would look at TKGs at vSphere with Tanzu. Any real-world scenario where a customer would use vSphere pod, please? It's an interesting question because I've tried to find use cases for it. I think because it allows you to integrate very deeply with NSXT, it enables certain security features that you wouldn't otherwise have. So I think in certain environments, where you really want to be able to do the NSXT firewalling, that would be a possible use case. Also, because they're running in ESX, they're closer to the hardware, which means I think that enables more options around integrating with various parts of the hardware. So think of like NVIDIA solutions, things like that. I know some announcements were made today around TKG support with NVIDIA, but I don't know the details around those. So maybe that also requires running them in ESX. I don't know that for sure. Where can we find the slide deck? Yeah, the slide deck will be made available. I think we're going to share them on GitHub actually. And if you reach out to me on Slack, I'll just send you the slide deck right now if you want. Will there be any more packages in TCE like load balance and MetalLB? Good question. I don't know. But the cool thing about TCE is they have their own channel in the official Kubernetes Slack. So we can just go in there and ask them, and they'll give us a straight answer because it's an open community supported version. So let's ask them in there. In fact, I think I was spending a lot of time in there yesterday, and I think I saw that question. So I think what they've done with these packages is they created a framework around the Carvel tooling. So things like a cap controller. And I think the whole idea is that the community can make as many kinds of packages as they want. So I mean, MetalLB is an obvious one to add, right? So I'd expect that someone to produce that pretty quickly. Let's see, anything else? Okay, well, if there's no one else, I'm going to thank you all for your time. And like I said, you can reach out to me on Slack or on Twitter, and I'm available all night. So speak to you there. Thank you very much.